Assalamu alaikum to you all. In lecture 1, we identified rational agents as central to our approach in learning about artificial intelligence. In this lecture, which is titled Intelligent Agents, we shall try to make this notion more concrete. That's the notion of intelligent agents. So here are the topics that we shall cover in this lecture. We begin by examining agents, their environments, and the relationships between the two of them. Then we look at the concept of rationality. We then look at rational agents. Then we look at the nature of environments. As you will see, there are different kinds of environments. Some are difficult to deal with and some are easy. So naturally, the agents that will work on difficult environments will have to be more intelligent than others. And then finally, we look at the structure of agents. We shall see skeletal design of different kinds of agents that will operate on different environments. Okay, so let's start with the first topic, agents and their environment. An agent is basically anything that can be viewed as perceiving its environment through its senses and then acting upon that environment through its actuators. As you can see in this figure, so we have an agent and we have environment. So using its senses, the agent will perceive information about its environment, and then based on what it receives, it will act. So it has actuators. I will give examples of sensors and actuators in a moment. So based on the percepts it receives, it will then do some action which will affect the environment. Let's take some examples. If you take human being, for example, as an agent, we have a number of sensors like our eyes, our ears, our nose. All the sensory organs that we have can be considered as our sensors. And then we have actuators, the organs that we use to perform some action. Examples: our hands, our legs, our mouth, and so on. So this is the same way we want to consider artificial agents. If you take a robotic agent, for example, as you can see above, the sensors could be cameras, infrared range finders, and so on. So these are the things the agent will use to perceive its environment. And then its actuators could be a number of motors that will enable it to do some action on the environment. Okay, so here, for example, the robot could be moving, so the legs could be considered as its actuators, or it could be using its arm to pick certain objects. So in that case, the arms are part of its actuators, and so on. Now, an agent doesn't have to be a physical thing like a robot or a human being. It can actually be purely a normal software that we know. So you can have software as an agent. In that case, keystrokes, file contents, and network packets that it receives can be considered as its sensory inputs. So the keyboard is, in that case, a sensor which is used to receive input from the user. Okay. Network card, for example, could also be used as a means of receiving information. So it is can be considered as a sensor, and so on. So based on these inputs it receives, the software will now do some action, usually by displaying its output on the screen, or writing the output to files, or sending the output over the network, and so on. Yeah, so it doesn't have to be a physical thing like a robot for it to be an agent. It could as well be a software, purely software running on your computer or on your phone, and so on. Now let us make certain terms more clear by way of definition. The term percept, which we shall use often, refers to the agent's perceptual input at a given instant. Okay, so the signals the agent will receive, for example, if it is software and the user type a letter A at that particular time, so the letter A is considered as a percept, and so on. So a percept is the perceptual input that the agent receives at a given instance. Then we have the term percept sequence. Now this is a complete history of everything the agent perceived so far. So all of it put together is called percept sequence. Now the agent will also have a function which is called agent function. Okay, it usually maps percept sequence to actions. So based on the percept sequence it receives, it will do some action. So the function that determines what that action will be is what is referred to as the agent function. Alright, now once we know the agent function, then we can go ahead and develop the agent program. So this agent program is the one that will actually implement the agent function. And of course the program must run on a particular physical architecture. For example, it could be a robot, it could be a normal computer, it could be your mobile phone, and so on. Any device where that agent program has been deployed is known as architecture. So actually you have to combine the two to have an agent, the agent program and the architecture on which that program will run. These two put together is what is known as an agent. Let's give an example of an agent, very simple one in this case, vacuum cleaner. So suppose we have a very simple vacuum cleaner agent where the agent will be working on an environment consisting of two squares, A and B. The agent perceives two kinds of information. One is it will be able to perceive which square is it in. Is it in A or is it in B? Maybe its camera as one of its sensors will tell it where it is right now. So the agent can perceive whether it is in square A or in square B. It can also perceive whether there is dirt or not in the square where it is at the moment. What kind of actions can this simple agent do? Three kinds of actions. So it can choose to move left, assuming it is in square A. It can move left to square B, move right, If it is in square B, it will be able to move to the right. And the third one is it will be able to suck up the dart if there is dart where it is. So move left, move right, suck up the dart are the three actions that this very simple agent can do. And therefore a very simple agent function for this vacuum cleaner could be defined as this. If the current square is dirty, then suck. Otherwise, move to the other square. So if you are in A, move to B. If you are in B, move to A. This defines the function of this very simple agent. And this table shows a partial percept sequence. Remember, percept sequence is all the history of the percept the agent receives. So this table can grow indefinitely actually, because each time it receives a percept, it will be added to the sequence. And the action it will do, based on this definition of the function, will be what is stated here on the right. So of course, if it is in A and A is clean, move to the right to go to B. If it is in A and it perceives that the A is dirty, then the appropriate action to do is suck the dart. If it is in B and it perceives that the square is clean, then the appropriate action according to this function is move to the left. Okay, so this is a very simple example of an agent. The next question is, what makes an agent good or bad, intelligent or stupid? This is what we are going to discuss in the concept of rationality. Now, a rational agent is one that does the right thing. The question is, what does it mean, doing the right thing? Well, doing the right thing is determined by looking at the consequences of the agent behavior. You know, an agent will be generating a sequence of actions based on the percept it receives. And this sequence of actions cause the environment to go through a sequence of states. The question is, are these sequence of states desirable or not? Alright, so if the agent's actions causes the environment to go through a sequence of desirable states, then the agent is said to perform well, or to behave well, or to be rational. Now, how do we determine this desirability? It is usually captured by a performance measure. This performance measure evaluates any given sequence of environment states. So based on the value obtained, we can then say whether the agent behaved well or not. Example of performance measures for the vacuum cleaner could be the amount of dirt cleaned up, the amount of time taken, the amount of noise it makes, and so on. So the performance measure is not unique, as obviously you can see. It depends on the particular agent and the particular problem. But there's a rule of thumb. As a general rule, performance measure should be based on what the environment should be. In other words, what is the consequence of the action of the agent, not necessarily based on the agent's behavior, but has it performed as well as it should, considering the output it is supposed to achieve, basically. Alright, so the performance measure should be based on the environment. To give you an example, this vacuum cleaner agent, if we say, for example, performance measure should be evaluated based on the amount of dirt cleaned up. This doesn't sound very good because, for example, the agent could suck up the dirt in one square and then throw it in the other square and then suck it again. So over time it will be accumulating a lot of dirt. I mean, it would be cleaning a lot of dirt, but actually it's the same dirt that it is spreading and cleaning up. So just the amount of dirt probably is not a good way to evaluate the performance. Maybe a better one could be the cleanness of the two squares relative to time. That's probably a better performance measure than just the amount of dirt. In any case, the idea is the performance measure, how to arrive at it depends on the agent and also the environment. We are moving towards having a good definition for a rational agent. So here it says, what is rational at any given time depends on four things. One is the performance measure that determines the criteria of success, as we explained in the last slide. So one has to look at the performance measure, how well is the agent doing based on that performance measure. It also depends on the prior knowledge of the environment and the actions that the agent can perform. And finally, the agent's percept sequence to date, the percept history, or the history of the percept that the agent receives. So meaning the information the agent received. If you add all these four together, will determine whether the agent is rational or not. And here is a good definition for a rational agent. Say for each possible percept sequence, a rational agent should select an action that is expected to maximize its performance measure, given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. Alright, so if you notice, this definition takes care of all these different parameters that are supposed to be taken into account in determining whether an agent is rational or not. Okay, so this is basically what is meant by a rational agent. An agent that tries to maximize this performance measure based on this is called a rational agent. There are a few points to note before we move on. One is that we must distinguish between rationality and omniscience. Omniscience means all-knowing with infinite knowledge. Perhaps only God will be that. So we're not aiming for perfection in rational agents, just that the agent should try to maximize its performance measure based on the input it has received so far. Okay, the other point to note is that agent can perform actions in order to modify future percepts so as to obtain useful information. This is called information gathering or exploration. For example, our vacuum cleaner, we assume that it has prior knowledge of the two squares, square A and square B. But suppose it doesn't know this prior knowledge, then maybe the first thing it should do is to explore its environment to identify what are the squares it is supposed to be cleaning. So this kind of information gathering is normally expected also of rational agents. The final point or definition we should note is rational agents should also be autonomous. So what does it mean to be autonomous? An agent is autonomous if its behavior is determined by its own percepts and experience with the ability to learn and adapt. Yani the experience here meaning it should take into account the previous history and learn how to adapt this history in deciding what action to take in the future without depending solely on the built-in knowledge. Okay, if an agent can do that, then it is said to be autonomous. Right, so this is very important. A rational agent should be able to learn from its history or from its experience and adapt that knowledge to obtain better outcome in the future. Okay, so now that we have learned the definition of rationality, we are almost ready to start designing rational agents. However, before we do that, we must discuss about the task environment. So this is what we're going to discuss, nature of environment. Yes, the environment basically are the problems to which the agent is the solution. So before we design an intelligent agent, we must specify its task environment. The acronym PS is normally used as a shorthand for the things that we must specify to fully describe the task environment. And the full meaning of PS are P is for performance measure, E is for the environment, A stands for the actuators, and of course S is for the sensors. Yeah, so for each agent that we are trying to design, these four things must be clear. What is the performance measure? What is the environment under which the agent is going to operate? What actuators does our agent has? And what sensors does it has through which it receives its packets? We're going to take a few examples to demonstrate how to determine this PS or how to specify the PS. Let's take an example of a taxi driver, automatic taxi driver. In such case, the performance measure could include safety. So, of course, if the driver will crash, then it is not doing well, and therefore it will not be rational. It should be able to reach its destination as fast as possible. Obviously, this may compete with being safe, so there has to be something in the system to try to balance these two goals. Okay, so how safe, how fast, how legal, it must follow all the rules on the road, and also how comfortable the passenger will feel during the trip, and also, of course, the driver is trying to gain some money, so the profit that is achieved by the driver will also be factored in determining the performance measure. So these are some of the key points to take to include in determining the performance measure of this particular agent, which is taxi driver. So next up is environment. Wonder what environment will this agent operates. Obviously, the environment in this case include roads, other traffic, that is other cars that are moving on the same road, pedestrians, and the customers that the taxi driver will be serving. This will all form the environment. What about actuators? Well, the taxi driver will be acting on the environment using his steering wheel to turn left or right, at the accelerator, the brake, the signal to indicate to other cars which direction it is moving, and maybe horn to attract attention of other drivers, and so on. So these are the kind of actuators that naturally this agent will have. What about sensors? A taxi driver agent normally should have cameras, sonar, speedometer, GPS to know its location, odometer to know how fast it's moving, engine sensors to know how good the engine is. For example, if the engine is getting too hot, definitely there's an issue. So the driver should do some action in response to that. We may also have a keyboard through which the passenger can specify his destination, and so on and so forth. It could also be a mic through which he can speak, and the agent could hear and decide what to do. So this is one example. Let's take another example, medical diagnosis system. What is the PS for this? Well, the performance measure in this case, of course, we want to have a healthy patient, and then we need to minimize costs and avoid lawsuits. Yeah, so because in the Western world, for example, very often a patient takes the doctor to a law court if he thinks he is negligent in doing his duty, and so on. So these are things that should be considered in this agent as performance measure. The environment, of course, is the patient, the hospital, the staff that are operating together with the agent, and so on. Actuators, screen display generally to display questions from the agent to the patient so that the patient can read and then respond, to display the result of test or the tests that need to be done, diagnosis, treatments, and referrals. Yeah, so this generally can be displayed on a screen, but also the agent could mention some of this through its speaker. So speaker could be one of the actuators actually. Sensors, generally keyboard to enter the symptoms and the findings and the patient answers, and so on. Could also be mic. Basically any device that can be used as input could be considered as one of the sensors here. Another example, part picking robot. So here you could imagine, for example, in a factory, we may have a robot that is monitoring items as they are moving over a conveyor belt and picking out those that are defective, putting them in a certain bin, and allowing only those that are in good condition to move forward to reach to the packaging area, for example. So what are the PS for this? Well, performance measure is, for example, percentage of parts that are in the correct bins. What percentage of defective items are in the defective bin, and what percentage of good items are in the good bin. The environment is the conveyor belt with the parts moving on it, and the bins where he will be putting the parts that he picked could all constitute the environment. Actuators are the jointed arm and hand of the robot which he will use to pick these defective items, for example. And the sensors could be the camera, joint angle sensors, and so on and so forth. Basically the things he will use to perceive the items and decide what action to take. Okay, so the next subtopic is the nature of environments. The range of environments that arise in AI is very vast, as you can imagine. However, we can identify a fairly small number of dimensions along which task environment can be categorized. These dimensions determine to a large extent the appropriate agent design and the applicability of different techniques that we're going to learn through this course for that particular environment. So we're going to first identify these dimensions, and then we try to take some examples to make sure the ideas are clear. So the dimensions first. First, an environment could be fully observable or partially observable. So when we say an environment is fully observable, if an agent's sensors can give it access to the complete state of the environment at each point in time, then we say that the environment is fully observable. Again, as I said, we shall take examples later to see what are fully observable environments and what are partially observable. But there's an advantage to having a fully observable environment. No need to maintain an internal state to keep track of the world of that environment. Again, this will be clearer when we take more example of designing the agent later. The second dimension is that an environment can be deterministic or stochastic. If the next state of the environment is completely determined by the current state and the action executed by the agent, then the environment is said to be deterministic. So from the current state alone and the action that will be determined, the action that will be taken by the agent, if they can tell us what the next state is going to be, then the environment is said to be deterministic. Now there are environments where the action depends on other agents, so multi-agent environment. So the action the agent is going to make will influence the action of the other agents operating in the same environment. If that is the case, then the environment is said to be strategic. So again, the advantage of an environment being deterministic is that we don't have to worry about uncertainty, especially if the environment is fully observable and deterministic, then there is no issue of uncertainty. Again, we shall see example of this later. The next dimension is episodic or sequential. If an agent's action is divided into atomic episodes, that is, decisions do not depend on previous decisions or actions, then it is said to be episodic. Okay? Otherwise, it is said to be sequential. Advantage of being episodic is that the action in each episode only depends on that particular episode itself. It doesn't affect other episodes. Next dimension, environment could be static or dynamic. So if the environment is unchanged while an agent is deliberating what action to take. Okay, so an agent receives a passage and it is trying to determine what action to take. If the time it takes to do this deliberation doesn't involve changing the environment, then the environment is said to be static. Okay, but if it will change, while it is trying to decide what to do, then it is said to be dynamic. Now, the environment is semi-dynamic if the environment itself does not change with the passage of time, but the performance score of the agent will change, then it is said to be semi-dynamic. You can imagine, for example, if you are playing a solitaire game and you are trying to time yourself to solve it within certain minutes, then yes, the decision you make or the time you take to deliberate, to decide what action to take or which card to move to another location doesn't change the state of the environment, but it will affect your score. Okay, so in that case, it is said to be semi-dynamic. Alright, so the advantage of static environment is that we don't need to keep looking at the world while thinking about the decision to make currently. Okay, another dimension is discrete versus continuous. If an environment consists of a limited number of distinct, clearly defined environment states relative to time, passage, and actions of the agent, then the environment is said to be discrete. But if you cannot identify these distinct states relative to time, then it is considered to be continuous. Example is taxi driving is clearly a continuous state environment. It's a continuous environment. It is continuous state, continuous time problem. So it is a continuous environment. The last dimension is that an environment could consist of a single agent or multiple agents. So an agent operating by itself in an environment obviously will consist of a single agent. Yeah, so if the actions of other agents do not interfere with the performance measure of this particular agent, then it can be considered as a single agent. So as we said, to understand these different dimensions, we're going to take examples. Yeah, so this is saying note depends on whether maximizing B's performance minimizes A's. Yeah, so there could be multiple agents, but are their performance going to affect mine? Obviously, in a situation like a game, chess game, the performance of one player will affect the other. So it's clearly going to be multi-agent. In fact, it's called a competitive multi-agent environment in that case. But there could be multi-agent environment where the agents are cooperative. For example, in taxi driving, ensuring that there are no accidents on the road. All agents will try to do that because the safer the environment, the better for all of them. So in that case, this is called a cooperative multi-agent environment. Yeah, so multi-agent environment can be competitive or cooperative. Now, clearly, the hardest of all environments will be one that is partially observable, multi-agent, stochastic, sequential, dynamic, and continuous. If you have an environment that is this, then obviously you have a hell of a task to design an agent that will operate on this environment. And taxi driving is an example that actually satisfies all of these. So it is a very hard agent to actually develop and implement.